What's up, ladies and gentlemen, YouTube, everybody out there, it's Philip20. Well, I'm back today, and I told you before I had some stuff I wanted to do with this system. Now I've got a couple of the parts. Tried to pick up a fan motor, and silly me, I didn't look underneath the cap, and it's a different type of fan motor. So I'll be taking this one back. It's used, everything I'm putting together pretty much is used junk. Throwaway stuff. So a lot of the stuff you could get straight out of a heating air conditioning company. These compressors, they're about 250 bucks, but I wouldn't suggest even consider buying one for the foreseeable future. So you go out and find you a unit that don't have a leaky coil, and you need a single speed system. Most systems are single speed, but unfortunately this one wasn't. So I've got a single speed fan, reversing valve heat pump control system. It's got all the plugs and gizmos and gadgets, whatever you want to call it. It's got everything that we need. And I'm actually just going to show you how I'm going to do it right here. So without further ado, let's get started. The defrost board's the main component, and for the controls, this will work perfectly fine. It will be an excellent setup. Let's go ahead and pull all these wires off. To be honest with you, I don't have an electrical diagram, but I'm not a bit worried about getting this thing functioning. On the back for any burnt spots. Typically you don't really see any burnt spots on these things. It's only low current. The only thing that's got high current goes through it is this thing, high voltage, high current. This is the relay that turns it on, the fan on and off during the defrost cycle. The low current is thermostat wires. Like it's big fat connectors, but it don't use a lot of current, which is fine. Here's our power in. Black is common, which is C right there. Yellow's W and Y. W2, which is your electric heater that goes inside the unit, is white. Red is power. O is for the reversing valve. It energizes an air conditioning cycle. And DFT is your defrost switch. And also you've got the time delay. I'm going to set that to 90 minutes. And you got a test, so we can test it after we get it installed and powered up. So we got an extra wire here that is to go to the contactor. I'm going to go ahead and put it right there on the contactor. And then we're going to go ahead and put our circuit board on. Now, this thing should have an electric heater on this thing, just a small, 40-watt heater at the very bottom of the compressor, which at the moment I don't have that, but I'll live through it. We have these orange wires, which are going to go in between here. I'm just going to splice those in, and then I'll just take this connector out. We don't need it. We don't need that connector at all. These are going to control the reversing valves, power on and off. And here's more for that, and our contactor, power on. And I'm just going to jumper that in case I ever need to use common wire for this specifically. So we've got our thermostat wire and our defrost wires go to the 60-30 switch. Now the other 60-30 switch is technically it's not a 60-30 switch. It is a actual resistive temperature sensor. And I can't use it. This is a resistive temperature sensor and it measures the actual temperature. This one, it just, it's an open circuit and closed circuit. When it reaches a certain temperature, it closes at 30 degrees and it's supposed to turn open at 60 degrees. So this will have to go on the same spot that my temperature sensor came off of. And it's got a clip that just snaps into place. And that's done there. And then I'm just going to feed this right into the defrost part there. So now all we got to do is tie these orange wires together. And our cutoff switch is going to tie to one of these circuits that goes through the switches that turn it off, the pressure switches. All right, so we got two pressure switches and they're run through each other. So one pressure switch has the pink wires, one has the yellow wires. So what I'm going to do is I'm going to bring the power to the contactor through this pressure switch, which is the high pressure switch cutoff. That's going to follow the power circuit through the other pressure switch, which is the low pressure cutoff. And then from there, I'm going to connect it to that low pressure switch cutoff. So these are on-off switches again. These are pretty much similar to the other ones. This one, what it does, this is a pressure switch here, and power feeds through it and then back out unless it has too much pressure or not enough pressure. And this one, I broke it off. It really doesn't matter. But we got both sets here, so might as well use both sets. If pressure gets too high because something's wrong, I mean, we're doing an experiment here. Why not have it shut off anyways? So it'll automatically switch back on. These are auto pressure switches, which is kind of nice. So that is the purple and the yellow red striped for this. And it'll tie into the contactor will be this wire here, and this power from the circuit board, which is the power that goes to the pressure switch, which we already cut because I don't want to reinstall a pressure switch, so I don't care. I already got some. It's just easier to wire nut it. And then once that's done, all we have to do is put a fan here, and the compressor wires that still need to be tied up. We want to do the pressure switches real quick. So I went ahead and pulled all my connectors out. I'm going to strip about yay amount back on the wires here. I like to twist them. Some people don't. Some people do. Do whatever you feel is comfortable. I'm twisting mine. I'm going to use these blue butt splice connectors. I'm going to crimp it thoroughly. We've got insects in here because it's at nighttime and lights be pulling. So we got bugs, but they're just beetles and bunch of beetles, big ass beetles. But when you're done with your connector crimp, it's always a really good idea to pull as hard as your fingers can pull it. That way you know for sure it ain't gonna collapse out. So I know which wires we got. We've got the two purple wires and the two yellow wires. And since we're running these in series, we're going to run the power going out through the purple one for now, which, I mean, it doesn't really matter which one it goes through as long as it's in series going to the contactor. and you want to crimp it. You want to pull on it with all your strength, with just your thumb and your fingers. It should not be able to come apart. And if it does come apart, you didn't do it right, and start over and try again. Figure out what you're doing wrong. And we're going to do this again with this. It's the yellow and the yellow-red wire, which the yellow-red wire is one of the other power circuits and the contactor wire itself. So let's crimp one side at a time and get that done. So it broke off. It was a bad connection. We'll start over again. Sometimes that happens if you strip it up on the wrong end. I may have stripped it on the wrong location, probably more than likely. So none of the wires should be broken off whenever you're stripping it. But you know, it is what it is. I didn't do it right, so I pulled on it as hard as I can with just 2 fingers. If it breaks off, just replace it. It's not that big a deal. Nobody's perfect, and crimps ain't perfect neither. You always got to test them. If that was a high current circuit, it would get hot and cause a fire. But since it's just 24 volt circuit, this is all 24 volt circuit mostly. So it really doesn't matter. I mean, I didn't have to pull on it, but it could have broke later, and then it would just be something I have to diagnose on the fly. And this is the capacitor wire for the compressor. It's our blue wire. I'm just gonna put a terminal on it like that. Actually, I don't like that specific terminal. I like these are a little better. The shiny metal terminals, I just don't like them. I just think they're garbage. This is a 10 gauge wire. And it fits in the 10 gauge terminal nice and snug. And then I'm going to crimp it. Now, again, pulling on the connectors. And I know somebody's going to point this out. It's loose, but it's low to the ground. As long as nobody pulls it up, it won't do nothing. But what I can do is add some electric tape or a zip tie and pull it to one side, which is what I'll probably do. And then once I got extra wire slack, I'll pull it down here, zip tie everything as organized as I can. So we got our reversing valve, and here's the reversing valve terminals here. And since I like plenty of slack, if I'm ever working on something, I'll just splice these connectors in as well. I don't want to have to deal with that later. And since alternating current is alternating, there's no such thing as polarity on this specific part. Polarity really wouldn't do anything or matter. Because alternating current is alternating. Unless you got a neutral, which the transformer probably has one, but I can't tell the difference between neutral on these circuits because they're both orange. So now this butt splice connector and this orange terminal. So we're going to make our connections here. and pull on them. Whenever you got connectors, you should keep them out of the weather. Everything in here is going to be weathered by rain, water, snow, sleet. You should keep your terminals either taped up and sealed, or you can hot glue the ends of your terminals and all around it. So just, I can leave it right here and pull it down to like there, and that would keep everything good to go. And we're going to pull these extra terminals here, this pressure switch terminals. That's what I'm going to do. I'm just going to go ahead and pull all these pressure switch terminals, other terminals inside. I'm going to seal it so I can zip tie and keep this compartment nice and neat. Now we do have an additional contactor for, I mean, I don't know, whatever I want. I could put something outside that's 230 volts and hook it up to this and just loop some wires into this, or loop it around and then back up and down. And then I can use this as a contactor for anything else I wanted to that's 24 volts. I mean, you could do all kinds of different things. You could do a water misting system, like if you want to be on the back porch and you want to walk up and flip a switch and turn on a water misting system with a solenoid. I've got one. I might have actually consider doing that and just run a line around the porch, and then I can go out and turn it off later, because I've got 24 volt power running this defrost board for continuously. So I could just run the switch in series with this contactor and have an on-off switch for like a water misting system outside or something. Keep you nice and cool. This thing's designed to keep us cool, which is good. We got real nice fat wires going to the compressor, and we just have this mess now that it looks like a mess, but all of our wires are wired up as required. So we have a power system that is basically ready to go. The only thing that's not wired up is the fan, and the fan will have 3, maybe 4 wires, 3 wires hopefully, 4 wires if we get a used universal motor. I have this fan motor, and it don't bolt up to the top. So what I'll do is take this one back and bargain with him again. I'm bargaining with him for this stuff. I was helping him out, and he's going to give me some stuff that I needed in exchange for me helping him out a little bit. So this is just pretty cool of him to help us out. Also, I wanted to see what size capacitor is here. I'd really like to have another 30 dual capacitor, because I don't have one, and I'll need a 30 dual capacitor, 30 plus 5 dual capacitor. This is probably a 35, maybe a 40, but more than likely a 35. This is a 35, and I don't know if it works, but I'm sure he wouldn't mind to have it back. He can use it. I don't need it, because I think it's good to have new capacitors. Only used capacitors for emergencies. I just don't feel right selling used capacitors. It's not a good deal. So basically, we have now wired up everything in the entire system. We've got a reversing valve wired up to these orange terminals. The terminals go all the way to here. The contactor wires are here. And the pressure switch wires here. So we're good to go. The contactor power wire, I believe, is this one, which is Y on the circuit board. And T1 is a pressure switch, I do believe. Hello, ladies and gentlemen. Thanks for watching all the way to the end of the video. There's lots more content coming. Click the subscribe button below. Make sure you come back for more, because there's great content always coming up every day in this channel. See you next time. Peace.